Okay, so this flashback is asking you to identify what type of reaction you have based on the given example. So, not their definitions, but their given example. If you remember their definitions, this should help make this flashback a little bit easier. So, let's look at some examples. Now, let's look at a synthesis example. Remember, a synthesis reaction is when two or more elements come together to make one new compound or product. So, an example of that would be Na, which is sodium, reacting with chlorine gas, which is Cl2, to react to give you NaCl, which is sodium chloride. So, if you remember synthesis, two or more single elements, we got two of them here, coming together to make one new compound or product. So that's what happened here. So this would definitely be an example of a synthesis reaction. Our second one is decomposition. And a decomposition reaction is when a compound can react with heat or light, for example. And when it does that, it'll break down into its separate elements. So for an example, let's say we take sodium chloride. We add heat to it, so it's going to react with heat. And then it's going to break into its separate elements. So it's going to give you Na plus Cl2. So if you notice, synthesis and decomposition are total opposites of each other. They're going to do the opposite of each other. So that is an example of a decomposition reaction. Our third type of reaction is single replacement reaction. And in a single replacement reaction, if you remember, we're going to have one single element that is going to react with a compound. And when it reacts with that compound, it's going to switch places with an element from that compound. The element it switched places with is the one that has the like charge of it, to give you a new single element and a new compound. So let me give you an example. So let's say we have HCl plus Na. Okay? Na has a positive charge, H has a positive charge, and Cl has a negative charge. So our single element here is going to switch places with someone in this compound. Now, it has to be the one with the like charge, so he's going to swap places with the hydrogen. And that will give you a new compound, which will be NaCl, and a new single element, which will be H2. So there is an example of a single replacement reaction. And you know it's single replacement because there's always going to be one guy by himself on the reactant side and one guy by himself on the product side. That's your giveaway for single replacement reactions. Our fourth type of reaction is double replacement reactions. We're going to abbreviate that DR. And an example of that would be HBr plus MgCl2 reacting to give you, okay, so let's walk through this. Now, in double replacement reactions, you have two compounds that are reacting with each other. An element from here is going to switch places with an element from here. It's always the one with the like charge. So H is positive, Br is negative, Mg is positive, Cl is negative. So that means Mg is going to switch places with the H because they're both positive. You switch with like charges. When it does that, it's going to give you two new compounds. So your new compound now is MgBr2 plus HCl. So that is an example of a double replacement reaction. And our fifth and final reaction is combustion. And remember, a combustion reaction is when a hydrocarbon, so when a carbon reacts with hydrogen. Okay, a hydrocarbon reacts with oxygen gas, which is O2, to make your products are always going to be the same, CO2 and H2O. So you know it's a combustion reaction whenever you see a carbon bonded to a hydrogen reacting with oxygen gas, O2, and your products will always be CO2 and H2O. And combustion is very straightforward and should be very easy to recognize. So now that you have been refreshed on examples of the 5 types of chemical reactions, you may now use this to help answer the questions correctly on your flashback.